So here the question is that this angle, let's call it theta 1. This angle theta 2 is the same as a book label. And so let's suppose this is T1. This is T2. Okay? So, and you have some gravitational force here, mg. And here, the idea is that if this is a uniform bar, then the mg, the center of mass, should be at the center. So it should be symmetrical. So theta 1 and theta 2 should be the same. If theta 1 is not the same as theta 2, that indicates the center of mass is not at the center of the bar. And you want to find the x. Okay, so you can see, first, usually we start with the torque balance equation. And in this case, it's better to choose here as our rotational center. Okay, when you write down the torque balance. Okay, and at this point I cannot say why, but later you will see the calculation is simple. If you choose other points, still possible, but calculation may be difficult. And so then you have three forces. If you choose here as the center, you don't have the torque from this force, but you do have the torque from T2, torque T2, torque T1. Together they will give you 0, and this is positive. This is negative, right? This is the center. So torque T1 minus torque T2 minus torque T1 equals to 0. And of course, that means T2 multiplied by R perpendicular 2 minus T1 multiplied by R perpendicular 1 equals to 0, right? Torque is always the corresponding force multiplied its own lever arm. But here, you should be able to find the lever arm. So this is the center. So this is R perpendicular 1. This is R perpendicular 2, right? Okay. And if this is theta 2, so this is theta 2. This is theta 1. So you can see R perpendicular 2 will be, okay, here. This hypotenuse is L minus x. Okay. So R perpendicular 2 will be the hypotenuse L minus x multiplied by, what's that? Okay, T2 is in front. And then R perpendicular 2 will be hypotenuse multiplied by, in this case, it's cosine, right?
I think seconds. Okay. Yeah.
And for torque 1, this is the hypotenuse. So it's x multiplied by cosine theta 1. It will be 0. Okay? So for these problems, it's quite important you need clear about the geometry here. And then you can rewrite this equation in a way. So this is T1 divided by T2 equals to.
What else would it be though?
Yes. So it will give you the ratio of two tensions in terms of x. And now, this is the torque equation. We still need the force equation, as I mentioned. In this case, it's better to use the x direction force balance. Okay, you can see along x direction, the weight wouldn't have any x component. So along x direction, the force balance equation is kind of like this. If we call this T1x, this is T2x. So we get T2x minus T1x should be 0, right? And T2x is T2 multiplied by sine theta 2 here, angle here, minus T1 multiplied by sine theta 1 equals to 0. So again, from this equation, we can rearrange to get T1 divided by T2 equals to sine theta 2 divided by sine theta 1. Now this is the ratio of the two tensions. This is the ratio of two tensions. So you can equal the 2. Finally, you get this. Right? So this is the equation for x only. You have all other numbers, angle, lengths. So you can solve it for x.
Thank you.
Yeah.
It's probably the easiest way to do it. Especially with drawing.
It's food. You always take what you use and then add something to it.
No, I don't.
Eight.
I usually assume correctly. It's not pompous when it's true.
Arrogant.
Sometimes.
Skill cut.
Oh, that's right.
I mean, if the center mass is all obviously closer on this side, that's why theta 1 small. That makes sense. I didn't see it.
He's never fun now.
I'm still trying to undo my screw. Figure out how you watch my
Like exactly where it is.
I'm just because like that's what I was about. That's what I'm trying to say.
Seems a lot like
Yeah, because I kept trying to that's why
Okay. It's all about the static equilibrium, right? The bar should be in the static equilibrium. So you should be able to write down the torque balance equation. This one is the torque balance equation. And the force balance equation. We just need one of the force balance equation, x direction. So what I'm doing is just write down the torque balance equation, force balance equation. This is the torque balance equation, right? If you choose here as the center, if I choose the center of mass as a rotational center, so we have a torque produced by T2 and a torque produced by T1. They are in the opposite direction. So the torque T2 subtract torque T1 should give you 0. Right? And then you can write down torque T2, which is force multiplied by labor R. Force multiplied by labor R. And here the key is that you should be able to figure out the expression for the labor R. So this is R perpendicular 2. This is R perpendicular 1. So from this triangle and this triangle, you should be able to find out R perpendicular 2 equals to this. R perpendicular 1 equals to this. Okay, you can check because that's hypotenuse multiplied by cosine theta. So they have different hypotenuse. L minus x, theta 2, theta 1. And then I get a ratio between T1 and T2 in terms of x. So I just put it here. And then from the force balance equation, it's much easier to understand. Along x direction, you have only two components, T2x and T1x. So they should cancel each other. That gives you another equation, which is T2 minus sine theta 2 minus T1 minus multiplied by sine theta 1. So from this equation, you can find the ratio of T1 over T2. So if you combine the two equations, you can get out this ratio. And you get one equation for only one unknown quantity x. Just solve it.
I got a question. Does this T2, does this have to stay in front of this? Could you
It doesn't matter.
Could you put
Mathematically, this is the same thing, right?
It's not like I get 100, but
It's the same thing. Okay.
Well, my question is, what about this? I thought this was a crossbar. Like, doesn't the R have to be?
yeah, you can sit down.
Okay. No. When you write it as this, torque equals to R cross F. Okay, yes. You cannot change the order. But I'm not using this. I'm using the magnitude of the torque. Here, I'm only caring about magnitude torque. Because I already figure out the sign. So yeah, so torque in this case equals to R perpendicular multiplied the force. This is just a scalar equation. You can write it in any way. Okay, that's different with this one.
Okay, that makes sense.
This one because you want to figure out the direction from the cross product. But here I already figured out the direction. Because that's a single question. Well, not single question, single direction.
Number 2.
What I did is I sent the whole thing with H. Does it come just H?
Sure.
Is it right?